So in the last session, we talked about creating a cluster using kubeadm method, right? So what did we do in this kubeadm method? So we took bare metal VMs. So we took bare metal VMs, that is EC2 instances, and then we used kubeadm method. So where we installed containerd as the runtime, okay, and then we installed kubectl and then kubeadm binaries, and what else? So we installed kubelet binary. Okay, so once the cluster is set up, we also installed pod networking plugin. Okay, so which is ViewNet. So how to set up your local Kubernetes cluster? Okay, so there are many methods. We use Minikube. Okay, so Minikube is a tool so that will help you in setting up a local Kubernetes cluster. Basically, it will set up only single node cluster. That is, it will have only master node. Okay, so slave nodes and all will not be available by default. But if you want to use Minikube for creating multi-node cluster, you can still do. But for practice purposes, one node cluster is more than enough. Okay. So this Minikube is supported in all three operating systems like Linux, Mac, and Windows. And you can create multi-node clusters as well. Okay. So before understanding how Minikube works, let's understand what is this kubectl. Okay. What exactly happens in this kubectl? So kubectl is the command line utility that we use to talk to the Kubernetes cluster. Basically, it directly talks to the API server, that is your Kubernetes API server. So whenever you issue some commands like kubectl run, apply, kubectl get, whatever commands, so those commands will be converted into the REST APIs that will be understood by your Kubernetes API server. Okay, but directly it will not be sent to the API server. Okay, so what happens is, so first whenever you run any command, first client side validation takes place. So what is this client side validation? Okay, let's assume that instead of kubectl run, you ran another unsupported command. Okay, so instead of that command getting failed at the API server end, okay, so we are failing it at the client side, that is at the kubectl side itself. Okay, because failing at that side is much faster. Let's assume instead of run, okay, so I gave kubectl running. Okay, if that command reaches the API server, it will fail in anyways because that is not supported. What we are doing is we are failing it at the client side itself. Like it will see for unsupported commands or unsupported YAML files or configurations. Okay, so that is the first step, that is client side validation. Let's assume you gave the correct command. Okay, now I gave this command like kubectl get pods, so that should list all the running pods in your cluster. Okay, this particular command is correct. So first step is passed. Now the second step, what is the second step? So directly you cannot make an API call, or kubectl cannot directly send that API call to the API server without actually inserting the authentication information. Okay, like who is the user, okay, whether he has sufficient permissions or not. Okay, so not sufficient permissions. Okay, so that is the third step. So first thing is that user information has to be added to that API call. Okay, because let's say that there is this X user. Okay, so assume this X user, without having any proper authentication, controls the API server. It should not happen, right? So what happens in the next stage is, so this kubectl will read the kubeconfig file. Okay, so we call it as Cubeconfig, but there is no specific name for it. This file will exist under your home directory under .cube folder. So there will be a file called config. Okay, so this we call it as Cubeconfig. So kubectl will read this file, fetch the authentication information, and then it will add to that particular API call. So that happens in the second step. Okay, so your kubectl will form that REST API request, including the authentication information, certificates, tokens, etc. So it does by reading the kubeconfig file, and then it will form that API call. Okay, so let's say you intend to basically list all the pods. Okay, so there will be an API call. Okay, so that API call will be usually in the form of some URL slash API slash v1 slash pods. Okay, let's assume. So along with this URL, authentication information will also be added to that REST API call, and then it will be sent to the API server. Now API server does a lot of things. So first it will perform the authentication. Okay, so whatever user information in the form of certificates and keys, let's assume. Okay, so that information will be authenticated by the API server, whether this particular user is actually an authenticated user or not. Okay, if he is not an authenticated user, the request will be denied. Okay, let's assume that he is an authenticated user that Kubernetes can detect. I mean, your cluster can detect. Next is the authorization part. So what is this authorization part? Authorization part is whether that particular user can actually list all the pods or not. Let's assume I issued a command, so that will delete a pod. Okay, so this deleting the pod requires special privileges. So your API server will check whether you have the particular authorization or not. That is the second. Okay, third is it will actually verify the whole API call. So if everything is correct, it does something in the cluster, like if you are asking for list of pods, so API server can send that response back to the kubectl utility, that is your client. So it may send the JSON or it may send the YAML. Okay, it will send a huge data. Okay, but reading that huge data is very difficult for you. So what kubectl will do is it will parse your data, and it will display only the required information, like the pod name, and in which node it is running, and maybe its IP address. Okay, I'll show you. So only the required information will be printed. Of course, you can configure that as well. So here, you should have the kubectl installed whenever you set up kubeadm. So if you remember, we are also installing kubectl. You can also install it separately, okay, without the actual cluster also. Then you can do kubectl version. Okay, so if you do kubectl version, it will print two versions. So one is your client, that is kubectl binary version. The second one is the server version. Okay, so your actual Kubernetes version that is running. Okay, so this is the client version, kubectl version. Okay, if you see, your client is 1.22, your server is also 1.22. So we have 1.26 as the latest Kubernetes version running. So let's install kubectl and find out whether kubectl is also at the same version. Okay, now coming to the Minikube. So Minikube is a local Kubernetes cluster creation kind of a software, which makes it easy to learn and develop applications of Kubernetes. Okay, it basically creates a single node cluster, but you can also create multi-node cluster, which is not a common use case, available for all three operating systems. Okay, it has inbuilt support for a lot of tools. Okay, so ideally if you install kubeadm, you need to install other tools like dashboard or any storage provisioners, etc. But Minikube comes by default with all these tools. Okay, so that your learning becomes much easier. Okay, in kubeadm, so ideally when you set up multi-node cluster, you cannot run any workloads on the master node. Okay, because master node is meant to run only the control plane. If you create a pod, it will create only in one of the worker nodes. But in Minikube, we only have one node, which is the master node. Okay, so ideally master node should not run any workloads, but Minikube, in Minikube we can run, because there is only one node. Okay, so if you cannot run on that node, since there are no other nodes, your resources cannot be created, right? Now there are certain prerequisites. At least two CPUs and 2 GB RAM is needed. In case of Windows, if you have 8 GB RAM or 16 GB RAM machine, that should be good. Okay, so 20 GB free disk space is the common space that will be occupied by your Minikube. Of course it will not use the complete, but since Minikube will create a virtual machine, that virtual machine will take 20 GB of space. Okay, so for all your operations and all. Okay, and Minikube will create a VM. Okay, so how does it create a VM? In case of Windows, you cannot create a VM in Windows, right? Without having any VirtualBox software or VMware software, you cannot actually create. So Minikube requires a hypervisor software, okay, or any virtual machine manager software in order to create that VM. Okay, so in case if you are are using Minikube in AWS EC2 instances, this high virtual machine is not needed because EC2 itself is a virtual machine. Okay, so Minikube can directly run it without needing any external virtual machine manager. But in case if you are running on Windows, okay, so Minikube cannot directly create that VM. So we will install VirtualBox. So whenever you create a Minikube VM or Minikube cluster, it will create a Linux VM. Okay, inside that Minikube will run. Okay, clear guys? Okay, so this is how you start a Minikube cluster. Once you install Minikube, we can use Minikube start. Okay, so you can directly use Minikube start without any further arguments. Okay, so by default it will take one vCPU I think, and I think one vCPU and 1 GB RAM. Okay, if this is not sufficient, you can pass the total memory that you wanted to give to that virtual machine and total CPUs that you wanted to give. You also have an option to select the version of Kubernetes that you need. If you don't mention, it will always take the latest one. And coming to the driver, this is what your virtual machine manager. Okay, so Minikube start hyphen hyphen driver is equal to VirtualBox. So this usually selects your VirtualBox as the what do you say, as the virtual machine manager. Okay, so inside VirtualBox you will see a new VM that is created by Minikube. Okay, since that is a VM, it has an IP. So if you do Minikube IP, it will display the virtual machine IP address, and also you can see all the add-ons on the screenshot. Okay, and most of them are disabled. And if you see, you have Istio, Ingress controller, Helm chart, dashboard, metric server, metal LB, Qvert. Okay, storage provision. There are a lot of things available here. Okay, so if you run kubeadm, usually these will not be even shown. You have to separately download and install them. But here in case of Minikube, you just enable it, automatically that particular piece of software will be made available. Okay, so I'll also show you what is this metal LB when we talk about load balancer configuration and why that is needed. Okay, so if you see, I am just running Minikube start hyphen hyphen driver is equal to VirtualBox. I have not selected any version, or I have not given any CPUs or memory values. So it is taking by default 2 vCPUs and this much amount of memory. Okay, and 20 GB is the disk space, right? And if you see, if you get an error here that your computer doesn't have virtualization enabled, so what you have to do is you have to enable it in your BIOS. Okay, and then you need to run the same command again. But even after enabling that virtualization in your BIOS, if you are still getting the same error, you can temporarily disable that VTX check, that is virtualization check, by using this particular flag. Okay, so how do you actually disable them? So you have to turn off certain features in Windows in order to make Minikube work. Okay, so you need to uncheck. Okay, so if you um, so how do you get these options? Anyone? Okay, just type turn on Windows features on and off. Okay, if you just select this, it will display all these options. You need to make sure that your hypervisor platform and virtual machine platform both should be turned off. Okay, so then it will turn them off. Then you can start Minikube using Minikube start driver is equal to VirtualBox. If it is giving an error, you just turn a virtualization check, but you need to enable virtualization from your BIOS. Okay, clear guys? Any questions? Okay, so I'll come to this again. So let's assume you wanted to use your own pod networking. So then you can pass the CNI plugin, which plugin you wanted to use. If you want to enable Calico, you use Calico. You can use Calico. And container runtime, basically it uses Docker. If you don't want Docker, you can use containerd, then automatically it will install containerd when it creates that VM. Okay, clear guys? And Minikube also has a dashboard. If you simply use Minikube dashboard hyphen hyphen URL, Okay, so it will display the dashboard. Okay, so what I'm doing here is, here I'm starting the Minikube cluster, but instead of one node, I'm creating four nodes. Okay, which means one will be the master, the three will be the worker nodes, and then CNI I'm using Calico, container runtime I'm using container D. So if you use this will also work. Then I can list all the nodes, I can create deployments and all. Okay, so if you want to delete the Kubernetes Minikube cluster, you do Minikube delete, or if you want to simply stop, because we are starting with Minikube start, you can use Minikube stop. Automatically it will stop your Minikube cluster. So whenever you need, you can simply use Minikube start again. Okay, so when you're starting it again, you don't have to pass these n value, CNI, container D values, because Minikube, once it starts, it creates a configuration. So if you do Minikube start, by default whatever configuration that you use, automatically that will be taken up. Okay, so you don't have to pass all these flags every time. Got it, guys? Any questions? Okay, so now let's start uh, creating the cluster. So for this, I will install VirtualBox. So download. So download for Windows. If you are on Mac, you can use Mac. So let's download for Windows. Okay. And now let's search for Minikube. Minikube start. So you can click on this. So this is the official Minikube site. You can go to the home page and everything will be given here. Okay. So get started. These are the minimum requirement: 2 VCP, 2 GB RAM and 20 GB hard disk. And if you are on Windows, you can click on this Windows x86 stable exe download. Okay, so if you click on exe download, okay, so it is not downloading, then click on this latest release, it will download. Okay, so first let's install VirtualBox. Okay, as I already said, you need to turn off your virtualization, turn on your virtualization in your BIOS. Okay, so if it is already there, that's fine. Okay, start VirtualBox. Okay, so there are some old VMs of mine. Okay, so don't care about all this. Now install Minikube. So I'm using all the defaults. Okay, completed. Click on finish. So now you can start your cluster. Okay, using Minikube start. So I will go back to the presentation. So what I'll do is I'll create only single node cluster, but this time I'll use driver is equal to VirtualBox because that is my actual driver. So if you want, you can also pass the memory and CPU values like this. Okay, so open any terminal, just paste it. It is saying Minikube version 1.29 on Windows 10, and it is downloading the Minikube related ISO files. Okay, let me show you how to install kubectl also. Okay, so I'll open one more terminal and then I'll try to run kubectl. So if you see, kubectl is not detected. So for this, we also need to install kubectl. just search for install kubectl, install tools Kubernetes, install kubectl on Windows. So you can use curl, or else you can just click on this latest release version 1.26. If you see, it is showing version 1.26. And here, so kubectl exe is not an installer. If you try to open this, okay, it will not actually run or create any setup. Okay, so why this is because this is direct executable file. So for this, what we have to do is, once you download it, you can just cut it. Okay, then you can paste it anywhere. So what I usually do is, inside my C drive I create a folder known as tools, and then I paste all the binary files here like kubectl, helm, ekctl and all. Okay, then this is the location of the binary, which is C drive tools. Okay, so this is not in my path. Okay, so always remember, every executable should be in the path, but in Windows, where is the path? Okay, so if you search for environment variables, edit the system environment variables. Now if you go to environment variables, so there are two set of variables. One is the user variables, the other is the system variables. Okay, so you can use system or you can use a user variable, it's up to you. So here in the system variables, I double click on the path and then add a new path, C drive tools. Okay, then click on OK and OK. You can also do the user variables. You can also edit the user variables path and add. If you see, I already have that path here. Okay, now your path is added. If you are pasting it in some other folder, try to add that folder location in the path variable. Okay, now your existing terminal will not detect that kubectl. You have to close any existing terminal, open a fresh one, and then do kubectl version. Now it is running. So kubectl, it is saying client version is 1.26, which is latest. But if you see, it is not actually printing the server version because there is no server. Okay, so here if you see, our Minikube cluster is set up. So it downloaded version 1.26 of Kubernetes, created VM of 4 CPUs and 4 GB RAM, 20 GB disk space. You can also see it in VirtualBox. See Minikube VM, it is running. Okay, and once you select it and go to the settings tab and system, so you'll be able to see the processes, one CPU. And if you go to the storage, not storage, general, I think it will show everything. Otherwise, if you select this, it will show here everything. Okay, so now our Minikube VM is running. So that's a VM actually. Okay, so can you SSH into that VM? Yes, you can SSH. All you have to do is you have to do Minikube SSH. You don't have to pass any credentials and all. Minikube will automatically handle it. So if you do Minikube SSH, the Minikube will allow SSH into its VM. Then you can type all Linux based commands. So even if you want any Linux environment, you can simply use Minikube environment. Then once you exit, you will be out of the Minikube VM. Okay, now if I try to run kubectl version, okay, so kubectl is also returning the server version, which is 1.26, because if you see the Minikube start output, so here your Minikube cluster is configured, sorry, it is created, and also your kubectl is configured. Okay, so which means your kubeconfig file is also updated to use the Minikube cluster. So that is the meaning of, which means that kubeconfig file is also created. Okay, so I can show you that. Okay, so for this, in order to navigate with Linux based commands, I can simply use git bash. Okay, and then here I can list all the files under .cube from my home directory. So if you see, I have this config file. So if I try to cat that config file, you will see Minikube. Okay, so let's not worry about the rest of the configuration. But Minikube has updated this Kubeconfig file. So this kubectl actually reading that config file, and it is able to connect to the actual Kubernetes cluster. Got it, guys? Understood? So I can try to create a pod and show you. So kubectl run. I will create an nginx pod with the image of nginx and the port, that is the container port or the nginx port 80. Okay, so the pod with the name nginx is created. Now let's get the pod. Okay, so pod is in the container creation state, but our main intention is to get the list of nodes. So get all the nodes. If you see, there is only one node by the name Minikube, which is in the ready state and assuming control plane is 3 minutes, and it is running 1.26 version of Kubernetes. Now if you get the pods, now the pod is in the running state. Okay, clear, guys? Okay, so here, let's say I um, you want to get into the Minikube. Okay, so I will do Minikube SSH. Okay, so now I'm in Minikube node. So we all know that pod is nothing but it is an encapsulation on top of a container, which means this particular pod should actually run as a container. Okay, since I'm already in Minikube, if I try to get all the containers, you will somewhere see the nginx container. Okay, see here, nginx image. This is the container id. So which means a pod is nothing but it's it's a container. Okay, it is a collection of containers. Okay, so in the end, in the back end, it runs the containers. Okay, so I can run any docker related commands. I can use this VM for docker, for practicing docker and all. Okay, now if I exit, i'll be um, I'll be back to the my Windows machine. Okay, clear, guys? So this is my git bash. So usually I won't use any of these terminals. Okay, so I always prefer VS Code. Okay, so once you open VS Code and click on this, so you'll have a terminal here. Okay, and then on the right hand side I can select the profile. Okay, so here I'm using bash. I can delete that terminal. I can go to the terminal again. I can create second terminal that is based on git bash. So now you can see there are two. So first terminal and the second terminal. Okay, so if you want the command prompt, so then the third terminal will be of cmd type. Okay, so if you don't want, you can actually click on this delete button. So now I have um, so what do you say, I'm on my Windows terminal only. Okay, so from here I can actually do all my operations like Minikube SSH. I can do it here, so it will be much easier to see, and also the UI looks much better in VS Code. So one important thing that I have to tell you is, so here, um, let me first delete this Docker binary, and let's close this terminal, or let's close this VS Code altogether. So I don't have Docker in my Windows. Okay, just a second, guys. I don't have Docker in Windows. In fact, I don't have even Docker client. Okay, but Docker is available in the Minikube. Okay, Minikube SSH. If you see Docker is available here. Even client tool is also available within the my Minikube. But my requirement is I have to connect to the daemon which is running inside that VM. Okay, So for that, Minikube actually provides certain environment variables. Okay, so if you just type Minikube env, not env, it is docker env. Okay, so it is providing you some environment variables. Okay, so here it is saying docker host. So docker host is pointing to a TCP port on some IP address and some port. Okay, so let's explore this. Okay, so if you remember, we already said that. So within the same VM, okay, so if you have your daemon part and if you have the docker client part, so using which method it is going to connect? It is through Unix socket, right? Guys, you should be very
Yes.
active, right? But I also said that what if my client is somewhere outside? Maybe my Docker system is somewhere, my Jenkins is somewhere, but Jenkins wants to create containers here. This daemon, I can expose it on some TCP port. Okay, so which means I'll expose it on some port here. So ideal it is 2376. Okay, and it also requires authentication. So there is an authenticated or a TLS protected daemon, or you know there can be an open daemon as well. Open daemon means anyone can connect, but TLS protected means it needs an authentication. Authentication means client has to authenticate itself with the daemon in order to talk to the daemon. Okay, so here 2376 is the port on which your daemon will listen, and this particular VM will have an IP address. Let's assume 192.168.22.1, something like this. Okay, so here this CLI, irrespective of its location, it can talk to this particular IP and port using TCP protocol, that is TCP, like this. Okay, to talk to the daemon. Okay, so earlier this CLI usually will read an environment variable, that is a docker underscore host. So docker underscore host will be pointed to a Unix socket like var run docker.sock. So that's the reason. So whenever docker CLI, if you issue any commands like docker ps or anything, it will first read the environment variable. This environment variable means where exactly your host is running. The host is pointed to this Unix socket. So this unique, if you talk to this Unix socket, which means you're talking to the daemon. Now what we will do is we'll change this docker host to point to the TCP protocol, which means if the docker CLI is here, we'll update the docker underscore host environment variable, which will point to this TCP. Okay, now if docker CLI runs any commands, it will take this as the address of your daemon. So assuming this particular Jenkins can talk to this particular IP address without any issues. Okay, because Jenkins should reach this IP. Okay, similar concept applies here also inside the Minikube VM. Okay, so let's assume this is your whole system, that is my Windows system. Okay, so here I have the Minikube cluster, okay, which is running Kubernetes. So inside this there is this docker daemon and then this docker CLI, so they both are communicating happily. And Minikube has an IP address, let's say 192.168.0.1. This is the Minikube IP address. Now this daemon, it is intentionally exposed on 2379 port. Okay, now in my Windows, if I just have the CLI, and if the CLI is configured with docker underscore host that is pointing to the Minikube IP colon 237, this docker CLI can directly talk to the daemon inside this VM, which means this CLI can talk to the daemon which is running in some other VM. Okay, so we just need to have the CLI, docker CLI. We don't have to have the docker daemon running in the Windows. Okay, got it, guys? You take any tool, it will be configurable either through a config file or through environment variables. So here Docker requires docker underscore host environment variable to talk to the daemon. Got it? Understood?
Yeah.
Okay. But how do I get the only CLI? Okay. So if you remember, we already talked about getting this uh, CLI from a link. Okay. So if I just go to this particular link, okay, so here it is Windows, okay, and then stable x86. If you just go to this URL, then you can select Linux, Mac, and all. See, I'm in Windows, so I'll just select Docker 23.01.zip. Okay, so let's just install it. I mean, just download it. So it will have both daemon and the CLI tool. So once you extract it, you'll find both. Okay, but I don't want both. Okay, so let's extract it. Okay, now if you check inside, so there is this docker d which is daemon, and there is this docker which is a CLI. Just cut the CLI. So we already have this tools folder where we are collecting all the binaries, and since this path is already added to the uh, environment variable path, okay, so just paste your docker CLI here. So now just close any terminal. Okay, so if you are using VS Code, then close VS Code and then try to open it again. Okay. Okay, so I'm in Windows. um, if I do docker, so now docker is there, but if I do docker ps, it won't, because there is no actively listening daemon, but daemon is running inside the minikube. Okay, so if I do minikube ssh and if I log in, so we can do docker ps and all. Okay, and I said, so minikube offers some environment variables of docker, those we can use. Okay, and also if you see the minikube IP address, this is the IP address which will exactly match this. Okay, now what it is saying is, so these are the minikube docker parameters. So if I can export them into my Windows machine, I can directly talk. So for exporting, so I can directly run this. Okay, so it will export all the minikube environment variables. See, I'm running in my Windows machine. Okay, so all the environment variables are updated in Windows. So now I can simply do docker ps from my Windows. I'll be able to talk to that daemon which is running inside minikube. So this is the standard method. So this is not related to minikube or anything. So this is how you connect a client with any remote server, provided a proper configuration is provided to that client tool. Okay, got it? Okay, so that is minikube. So there are other options as well. Okay, so there are certain add-ons that we can configure. So if you see minikube add-ons list, okay, so these are all the add-ons. So I can install Istio, and this is a third party. I can also enable the dashboard. So dashboard is basically disabled. Okay, so how do I do it? Just copy the the plugin name. Okay, so but let's check the help section. We didn't check it till now. So minikube hyphen help. So minikube start, stop, minikube delete, minikube dashboard to access the dashboard, and minikube docker env. Okay, which provides instructions to point your terminal to the docker engine inside minikube. And there are other options. So minikube ssh will let you ssh into minikube. Okay, and coming to the add-ons, it is there. So let's check the add-ons help. So you can enable, disable, configure add-on. Okay, list all the add-ons which we already did. Okay, so minikube add-ons list. and we'll enable an add-on by the name dashboard. Once you enable, what this will do is basically it will um, download that particular dashboard related files, and it will install. And also it is saying, in order to see the pod metrics, that is CPU and RAM, you need to also enable metric server. Okay, so I am also enabling metric server. Okay, I can in fact run kubectl top nodes. Okay, so if you see kubectl top nodes, so CPU and memory usage you can see, and kubectl top pods you can see how much CPU and memory that is being used by your particular pod. Okay, then it is fine. And since we enable minikube dashboard, okay, so I can use minikube dashboard hyphen url. Okay, so it will give you this url. Okay, so you can just pass this url. Now you'll be able to see the pods, cron jobs, daemon sets, jobs, pods, replica sets, stateful sets. Okay, you can click on pod. Okay, and then you can see the CPU and memory. Okay, so I think it is fixed in the latest version. Okay, that's good. So waiting for more data. It's in the running state. Some labels on the pod, in which node the pod is running, the status of the pod, which image it is running, the pod name. Okay, secret storage classes. If you see, there is a storage class, and then there are cluster RBAC, that is role based access control. Okay, clear guys. So this is the dashboard using which you can actually understand in depth about each pod. I think you cannot click on this pod to see more information. Yeah, so you can click on the pod name and see more information about the pod, like pod IP. Okay, the service account that is used, which is the default service account, and then there are events. Okay, so see the event. So first the container is created and then it is started. Container image is pulled. Okay, so okay, sorry, I'm showing in the reverse way, the reverse order. First is it is assigned to the minikube node. Okay, so this is done by the scheduler. Okay, got it. So scheduler scheduled it to this node, and then what kubelet did is kubelet instructed the container runtime to pull the image. Then the image is pulled, then container is started, and the actual container got created. You can see the the rest of the configurations. Okay, as you keep on adding pods, so this will be populated with the other pods as well. Understood guys? Any questions?
No, Vikram.
Okay, so let me install one more dashboard. Okay, so the dashboard is known as Kubernetes Lens, which is directly installed on the Windows. Okay, so the earlier dashboard was running internally to your cluster as another pod again, but here this will be installed directly on the Windows. Okay, so this is for all the operating systems. I think Mac, Linux are also supported. So we need to have the Kubeconfig file, and this cluster, I mean, sorry, this graphical user interface, the Lens dashboard will read that config file, and then it will talk to the Kubernetes cluster. Okay, and it will show all the resources. Okay, so let's go to their website, Kubernetes Lens, the Kubernetes IDE. So it is available for Mac, Linux, and all. So let's download for Windows. I think it will be pretty huge, some 300 MB. Okay, so all it needs is the kubeconfig file. So you can load any number of kubeconfig files, and you can actually see the information about multiple clusters here, not just the one. Okay, so here this is just the minikube cluster information, that it will display all the pods and resources inside that only cluster. Okay, so if you stop this proxy, okay, so that dashboard will not run. So if you try to refresh it, it will not connect. Okay, but this id is a standalone application that you can run it on Windows. Okay, let's set up. run.
Vikram, when we are running Minikube, can we deploy like two node? Can we mention like two node
Yeah,
and one?
I shown you, right? So minikube hyphen n. Okay, so I'll show you that as well. So let me parallelly do that. So in order to delete your cluster, you can use kubectl minikube delete. So this will actually delete your cluster. That is VirtualBox will be not the VirtualBox. Your VM will be deleted. Now I can actually start minikube using minikube start, and then so let me start minikube start. Now I'll select the nodes as let's say 2 is sufficient, and the driver is equal to VirtualBox, and total CPUs, let's say I need just some 4, and memory, let's assume 4 MB, sorry 4 GB, 4096. That's it. Okay, so this will actually create two nodes. So let's wait and see. Okay, since we already deleted this minikube, it will delete the Kubernetes Kubeconfig file also. Okay, so let's wait till this is created, then we will see the list of nodes. Okay, and one good thing about this minikube is you can dynamically delete a node and you can dynamically add a new node. Okay, with simple minikube add node, minikube delete node commands. So once this dashboard and all are done, from tomorrow we are going to start with actual Kubernetes concepts. So we'll start with pods, and we'll also understand the kubectl configuration, everything. Okay, I think kubectl we will see it today itself. See, now it is I think it is preparing one more node. I think, let's see. Yeah, so if you see, it is creating one more node. So the first node was called minikube hyphen zero one, I think somewhere. Yeah, so first node is called minikube, second node is called minikube hyphen m02. Okay, so that will be your worker node. Okay, so it is done. Let's just check the number of nodes. So now there are two nodes. So one is master, the other is your worker node, which is not in the ready state. I think it will take some time for coming online. Okay, so now let's move to the lens. Okay, so the software is open. Now activate lens dashboard, lens ID, lens subscription. Oh, I don't know what is this. Okay, so let me log in. Okay, so once logged in, it is redirecting me to the lens application again. Okay, yeah, so logged in, just confirm. Okay, it's not required. Now what we'll do is we'll load our kubeconfig file. Okay, so for this, go to file, add cluster. So it is asking you to paste the contents of the kubeconfig file which is available in your local machine. Okay, so here if you see, both nodes are in the running state. Now let's take our kubeconfig file. Okay, just take the entire file contents, go to the lens dashboard and paste it, and click on add clusters. See, cluster is now added. Okay, so now I can go to the home, or I can just select this cluster here. Now it will try to authenticate itself. It will display all the workloads. So on the left hand side I can select the workloads. Okay, so we don't have any pods, right, because we created the cluster again. Let's do one thing. Let's create a pod. Kubectl run nginx hyphen image is equal to nginx. So go to the lens dashboard, see the nginx. It is in the pending state, and now it is assigned to minikube m02. Okay, I can just go into the pod. So it is now in the running state. It is running in this particular node. This is the pod IP address. Service account is default. Okay, and the CPU memory. Okay, because we did not enable the metrics, right, like before, because we deleted the cluster and installed it again. We did not enable the metrics server. Okay, so I can also do that because it is minikube. It is very easy. So minikube add-ons enable metrics hyphen server. I think we can do minikube add-ons list and find that name. Okay, it is now enabled, but it will take some time to make the metrics available. Okay, so one important thing, one good thing about this lens dashboard is you can actually ssh into the pod, or you can go into the pod. So see here, ssh means, so how do you run a second command within a docker container? Using docker exec, right? Correct,
Yes.
guys? So here Kubernetes also, kubectl also supports the same kubectl exec, which basically let you into the pod, that is into the container, and run some second command. So from the lens dashboard you can actually do it by clicking on this pod shell. Then you'll be taken into the pod. If you see, actually your lens dashboard is running that kubectl exec in the backend. Now you're in the nginx pod. That's it. Okay, you can do a lot of things. Okay, with this pod I think you can edit the configuration in the real time, and also check the pod logs. If you see, I can directly see the logs without actually running any command. Okay, so it makes it easy to troubleshoot any issues inside the containers. Okay, right, I can do a lot of things with this lens. I can delete the pod directly from here. Okay, so the one of the best tool for learning Kubernetes. Clear, guys? Any questions? So that's it about minikube lens dashboard. Okay, any questions, guys? Anyone?
Vikram, in real time, we don't use this kind of dashboards, right? We go with
In
Grafana
real
and
time, we see, this is not a monitoring tool,
Mhm.
so I'm not monitoring any issues with the pod and all. Okay, I'm just checking the resources inside the Kubernetes cluster. There are thousands of resources inside the Kubernetes cluster, not thousands. I'm just saying like that. There will be tens of resources, right? So learning, understanding all those resources will be very difficult initially. Okay. So this lens dashboard makes it easy to visualize your cluster rather than monitoring your cluster. Getting?
Yeah, Vikram, got it.
Okay. So now let's understand a bit about this kubeconfig file, because so we have been talking a lot about this kubeconfig file. Let's understand the kubeconfig file by actually opening it. Okay, let me present it first. Okay, so what is this kubeconfig file? So here, being a cluster administrator, okay, so you will have access to tens of clusters, right? Okay, so some runs in AWS, maybe some runs in GCP, some run in your local cluster. Okay, so in all these cases, you will only have kubectl installed in your local machine, and this kubectl requires the kubeconfig file, which is this config file under this location. And now there are multiple locations for this particular config file. Okay, so there are three of them. So kubectl can read from any of these and get the cluster information, and then it can talk. Okay, so now if I have my cluster in AWS, that will have a different configuration. GCP will have a different configuration. Local cluster will have a different configuration. Configuration means IP addresses will be different, user certificates will be different, cluster CA certificates will be different. So there are a lot of things. Okay, so how do I manage all of this? Of course, if there is a kubeconfig file separately for all this, I can merge them together into the same file, or I can maintain them separately. Okay, so when I'm maintaining them separately, this kubectl has to be provided with the location of that file. Okay, let's assume that under root there is this kubeconfig file called 1.config. Similarly, there is one more called 2.config and one more called 3.config. Now these are not the standard location, so this is the standard location. Okay, so now let's assume this kubeconfig file is related to AWS, is related to GCP. Let's say this is related to the Azure Kubernetes. Now when I'm running kubectl get pods simple command, this usually refers to this file and whatever cluster that is provided inside this file. So the kubectl will contact the API server of that cluster. Now if I want my kubectl to use this config file, so there is a command. So kubectl kubeconfig without any spaces equal to this root slash one dot config, and the rest of the command like get pod, get nodes, whatever it is. Now this kubectl is using this config file. Now this config file will have different API server address pointing to a different cluster. Then kubectl will talk to the API server of that cluster. Got it? Understood, guys? Which means a particular user can have access to multiple clusters. Okay, which means there is a user. Okay, and then there are clusters. Okay, so let's say um, you know um, so I'm the user, but there is this user called dev, or how do we say? So let's say there is a user called A, B, and C. Okay, so both are, I mean, all are different. And then there are clusters called XYZ. Okay, I'm running kubectl get pods. Okay, so now which cluster this kubectl will contact? Correct? With what user credentials? Okay, what I'm doing is I'm the user, I'm the only user, but my usernames are different in all these cases. Okay, so in X cluster I'm called A, Y cluster I'm called B, in Z cluster I'm called C, but it is only me. Okay, So I intend to have only one kubeconfig file, that is only this, and I want to have all this information, like my A user details are here, B user details are here, C user details are here, X cluster, Y cluster, Z cluster configurations are all here. Yes, I can do that. You maintain separate config files or you club them together. Okay, that's fine. But if I run kubectl get pods, with what cluster I'm communicating? Okay, so that is called as a mapping. Okay, so what I'll do is I'll create a mapping. Okay, that is A user credentials are valid only to talk to, let's say, Z. Okay, B's user credentials are only valid to talk to X. C's user credentials are talk to Y. Okay, so here we have users, clusters, and then there is a mapping. So here mappings are A to Z, B to X, and C to Y. This is a mapping. So now what is the default or active map? Okay, so I'm saying CY. This is marked as active or current. What is the meaning of this is, whenever you do kubectl get pods, your kubectl is going to read C's user credentials and then it will try to authenticate with the Y cluster. Got it? Then you are all the time talking to the Y cluster with C's credential. That means C means it is only you, but you will have a different credentials for different cluster. Okay, so now my work is done with this cluster. Now I want to talk to the Z cluster. For Z cluster, I need to use A credentials. Okay, so already A to Z mapping is created. Now what I'll do, I'll make A to Z as the current or active mapping. So this is also known as context. Okay, so if I make A to Z as the current context, so whenever I do run kubectl related commands, so my A's credentials will be used to talk to Z cluster. Getting, guys? Got it? Guys, please respond.
Could you please repeat the last part for the C?
Okay, so now see here. So here I have a single config file. So there is this admin user, dev user, prod user. Okay, so there are three types of users, or maybe there is a single user, but maybe roles are different. So here these users means, so Kubernetes will not identify user. So there is no user database inside Kubernetes. Okay, it only understands the certificates and the keys. Okay, so here when I have three different types of users, they have different types of certificates and keys as the authentication. Okay, now all these users are there in the same config file, and then there are three clusters, all cluster level information are there in the same kubeconfig file. Now the mapping, that is the context. See here, admin user is allowed to only talk to the production. Okay, that's why a mapping is created. Here dev user is allowed to talk to Google, that is the cluster. Then there is a mapping. This dev user can also talk to the production. Then here that mapping, dev development, that mapping will also be created. You can create. Now only one of them should be active. So if I make dev user to talk to Google, so this is the context. So if I make it as current, then what kubectl will do? So kubectl command, whatever command you run, so it will take this dev user credentials and it will try to authenticate with this particular cluster. That's it. Okay, so let me show you a quick example. So for this, let's open our file that is inside the kubeconfig file. So we have this config file, right? Now see the example here. Okay, so now you'll understand. So here there are clusters, there are contexts, there are users. Okay, So let's not worry about this preferences. Let's not worry about this kind. Okay, so I'm just taking them somewhere. Okay, so the top three parts are YAML standard configuration. So there are clusters, there are users. Okay, so every cluster will have a cluster certificate, right? And then your API server URL. Okay, and then the name of the cluster is called as Kubernetes. Okay, got it? Okay, so this is a cluster. If you see, it is a list. So clusters is a list because I can have multiple clusters in the same Kubeconfig file. So one cluster is named Kubernetes, and this is the API server address of that cluster. Another cluster is called as a Minikube cluster, and this is the API server address of that cluster. And cluster CS certificate should be given. Okay, that is the cluster CS certificate. Now clusters part is done. Okay, so remember there are clusters called, one is called Kubernetes, the other is called Minikube. Now coming to the users, so there are two users. So one is called KubeADM, the other user is called Minikube, right? So there are Kubernetes cluster and then there is Minikube cluster. Okay, so there is this user called Kubernetes user, or Kubernetes -admin as the user, and then Minikube as the user. Okay, so now we don't know which user can talk to which cluster. Okay, that's the reason. See, user, if you expand the user, again user will have his certificate and key. So this is how you can authenticate. Now users part is done. Coming to the context, which is nothing but a mapping. So here we have a first mapping by the name of this, which is mapping the Kubernetes cluster and the Kubernetes admin user. That is the first map. Okay, there is one more mapping which is mapping the Minikube user with the Minikube cluster. Okay, this one, Minikube user with the Minikube cluster, and that context name is called Minikube. Okay, that is a shortcut of way of identifying. Okay, everything is set, but what we said is there can be only one active mapping, that is current context. What is current context? Current context is known as Minikube. So if you look at the context by the name Minikube, it is nothing but a user Minikube is being allowed to talk to Minikube cluster. Okay, so which means whenever you do kubectl run kubectl command, so this user certificates are used to talk to this cluster. So if you expand the user, if you take the Minikube user, so his certificates are used in forming the API call in order to talk to this Minikube cluster, and this is the API server. So your kubectl will form an API call in such a way that it will use this as the URL or the address, and this is the certificate to authenticate. And now to authenticate the user, it will use these certificates. Now your cluster will verify whether these are actually the certificates that is signed by the CA, then it will approve the authentication. Got it? Clear, guys? Okay, if you see the clusters, I have two clusters. Clusters means it will have the API server address and CA certificate. Users, I have two users, developer and experimenter. They will have their own certificate and keys. Now I need to map. Okay, so I know the developer can only access the scratch cluster. So then I'll create a mapping in the form of a context. Then I'll create one more mapping for this. Then I'll call it with separate names. Then I'll make only one as active. So here current context is not shown, so there will be current underscore context colon what context. So you can select any context, then that mapping will be used. Okay, so here one more thing, you don't have to navigate to this file. Okay, instead kubectl will offer you some commands like kubectl config view. Okay, so what is the use of this is it will read your config file and then it will display it directly here. Okay, you don't have to navigate to your home directory then go into .q folder. Okay, you can just simply use kubectl config view and it will just display. Okay, so for security reasons it will try to avoid displaying the actual certificate and the key. Okay, it won't show. Okay, but if you open the original file you'll be able to see. Okay, so there is also I think minify. Okay, so this will also show you, it will try to reduce the amount of information it will show in order to make you understand easily. Okay, so this is also supported. Got it? Okay, so here we will talk about these again later. Okay, so when we have multiple clusters or multiple namespaces, then I'll show you how to add a new cluster to the kubeconfig file or delete a cluster, or how to add a user, how to change the current context. Okay, so I'll talk about these later. These are not needed as of now.